Good day, class. Today we're going to discuss the different input signal modes of operational amplifiers. Last time we have discussed also the different input signal modes ng mga diff amp or differential amplifiers. It is important for us to understand these input signal modes, especially sa diff amp, because the diff amp is the input stage of an operational amplifier. Last time we have determined that there are two modes of signal operation. We have the differential mode and we have the common mode. So unahin muna natin yung differential mode ng ating mga input signals. Sa differential mode, basically, yung dalawang inputs ng ating operational amplifier ay merong magkaibang klase ng signal na inilalagay. The first type of differential mode signal is what we call the single-ended. So when we say single-ended, isa lang ang signal na ipinapasok natin sa ating operational amplifier, like this one. No? We have an input signal here applied to the inverting input of your op-amp, and the non-inverting input is directly connected to the ground. So that's single-ended. Pwede rin naman ganito. Itong ating inverting input ay directly connected sa ground, and dito naman natin ina-apply yung ating signal sa non-inverting input. So pwedeng vice versa. Either of those are called single-ended differential mode. The other one, which is what we call the double-ended or dual-ended, meron tayong ina-apply na magkaibang signals sa dalawang input ng ating operational amplifier. So for this example, we have one source for the signal, pero yung ating positive at yung ating negative terminals for the input signal ay in-apply natin sa inverting at sa non-inverting. So basically, this is out of phase by 180 degrees with the signal na nandito sa baba. Later on, I'll show you a circuit simulation using Multisim Live para maipakita na magkaiba talaga ang phase ng signal dito sa taas at ng signal na dito na nasa baba. So basically, this is still what we call the double-ended or the dual-ended mode of signal operation. All right. So here in Multisim Live, I have constructed a basic voltage divider circuit wherein meron tayong input AC signal that has a value of 1 volt and a frequency of 1 kilohertz. And we have two 10 kilo ohm resistors connected in series, hence we have a voltage divider. And then we have the ground in the middle of the two resistors. And I have connected two probes, one colored green and one colored blue. The colored probes are important because kapag nag-generate na tayo ng graph, ito yung makikita natin na color of the waveform at this point and at this point. Okay, so make sure it's set to transient and then press the run simulation button. All right. Remember, the green is connected to the top of your signal source and the blue is connected at the bottom of your signal source. So as you noticed here, for the green waveform, nauuna dito yung positive. For the blue naman, nauna dito yung negative. So they are out of phase by 180 degrees. So balik tayo dito sa double-ended or sa dual-ended na differential mode of signal propagation. As you can see here, meron tayong isang source lang ng signal. But as I've said a while ago, magkaibang phase nito and pinrove natin siya using a circuit simulation. So we have one signal here and another signal here that are out of phase by 180 degrees. The next mode is what we call the common mode. Sa common mode, meron tayong dalawang input for both of the operational amplifier inputs, one for the inverting and one for the non-inverting input. But as you noticed here, they have the same phase. All right? We can connect it in this manner. So meron tayong dalawang signal source, or we can connect it in this manner. So isang source lang, pero the same signal is being applied to your input. So those are what we call common mode signals. Take note, ha? Sa differential, they have different phases. No? They may have different values or polarity, kagaya no lang doon sa single-ended natin. Sa common mode, parehong-pareho yung ating phase. But usually, these common signals come from noise or electrical noise. We all know that noise is any unwanted electrical signals that is generated by any electrical means. So one example is the power source, no, yung ating power supply. It may produce electromagnetic radiation which can couple onto a circuit. All right. Another source is an adjacent transmission line which can be a source of interference to another transmission line. So ang noise na yan, sumasampa sa pareho na input natin. For example, this one is the noise and this one is also the noise. So again, noise is common to both the inputs of the operational amplifier. But if you can still recall the concept of common mode in the differential amplifier, ano bang nagiging output natin kapag meron tayong common mode signals? Remember, if we have common mode signals as applied to a differential amplifier, the output will become zero. So ang nangyayari dito, if we have two signals, namely your noise, na pumapasok sa dalawang input natin, it will eventually cancel out. Ayun ang nangyayari sa common mode signals. So this is mainly used for noise suppression. Naka-cancel out yung ating signal dito because of the common mode. We now go to common mode rejection. Hindi ko na diniscuss yung common mode rejection sa diff amp. It's because it's the same with the operational amplifier. What is CMRR? CMRR is basically common mode rejection ratio. Ang CMRR is actually a value na nagpapakita ng ability ng isang amplifier to amplify a signal but at the same time, i-reject yung common mode na signals. Remember, common mode signals, ito yung noise na sumasampa dun sa ating circuit or pumapasok sa parehong input ng ating operational amplifier. So kapag mataas yung ating CMRR, it means that maganda yung signal and maganda rin yung pagkaka-reject ng noise. Meron tayong equation for CMRR. So for this one, we have CMRR equals A sub OL divided by A sub CM. CMRR, again, is the common mode rejection ratio. Ano naman itong A sub OL? A sub OL is the open loop differential gain. Ang theoretical gain ng ating operational amplifier, remember, this is infinite. But in a practical manner, ang open loop gain ng isang operational amplifier is very high. Ang open loop gain, since this is very high, it is possible for us to have a saturation pagdating sa ating output. So how do we control the saturation? Naglalagay tayo ng mga external components, especially yung mga resistors, no? So we can have an inverting or we can have a non-inverting amplifier, no, para sa ating operational amplifier. Na-discuss nyo naman yan before in your lecture. So we don't need to expound on that. Ang A sub CM is the common mode gain. Remember, itong common mode na to, it pertains to the noise. Meron daw palang gain yung noise. In a practical sense, meron at meron pa ring gain na nakukuha yung noise natin. So this is dependent on the type of operational amplifier na gagamitin natin sa ating circuit. No? So ang mas magandang value dito is maliit lang, syempre. So later on, we will have an example to give you a picture of this CMRR. In decibels, we can express CMRR using this equation. So we have CMRR equals 20 times the logarithm of A sub OL divided by A sub CM. Ang CMRR ay nakadepende sa ating frequency. So whether it is low frequency or high frequency, your operational amplifier has different responses for the different frequencies. So let us take a look at this graph. This is a graph of the response of the operational amplifier based on the CMRR against your frequency. So as you noticed here, for example, you have a frequency of 0.01 hertz. The CMRR is 140. So it means that maganda yung pagkaka-reject ng noise natin and maganda yung pagkaka-amplify ng signal natin for this particular type of op-amp at this particular frequency. Halimbawa, nag-increase na yung ating frequency to, for example, 1 kilohertz. Ang magiging CMRR natin dito is 60 decibels. So compared with this one, mas maganda itong mas mabababang frequency compared dito sa higher frequency. But hindi naman pwedeng puro mabababang frequency na lang ipapasok natin. Of course, different signals have different frequencies. What if yung signal natin merong mataas na frequency component and others have low frequency components? So let us have an example for the calculation of CMRR or the common mode rejection ratio. Example, what is the CMRR in decibels for a typical 741C operational amplifier? Actually, itong 741 op-amp na to is a general purpose amplifier or general purpose op-amp. Isa ito sa mga paborito kong ginagamit sa circuits when it requires an operational amplifier. Kasi this is readily available and madali siyang i-integrate sa ating circuit. You can download the datasheet of the 741 op-amp from the internet. So just search it on Google and makikita nyo yung PDF ng ating datasheet. So for this particular type of example, ang sabi dito, ang 741C daw ay merong A sub OL na 200,000. Ito yung sinasabi ko kanina na ang practical value ng open loop gain ng ating op-amp is very high. But the ideal value is infinite. So how can we control this gain? We can control this gain by connecting different values of resistances like what I've said a while ago. But ang open loop kasi ginagamit natin for comparators. Take note, ang closed loop ginagamit natin for amplifiers. We connect external resistors pa rin sa open loop. But for closed loop, we also connect resistors but meron tayong feedback path, which is hindi ko na i-elaborate because you already have discussed that in your lecture with your previous instructor. Another given is the common mode gain is 6.3. The lower the value of your common mode gain, mas maganda. So if you want to have a smaller common mode gain, pipili ka ng operational amplifier that will satisfy the objective or the function of your circuit. Okay? So we have 200,000 as the gain for the open loop and we have 6.3 as the gain ng noise daw ito. So medyo malayo yung ating values. So here is the solution. So we will use the equation earlier. So CMRR is equal to 20 times logarithm of open loop gain divided by the common mode gain. Take note, both of the gains are unitless. All right. Substituting the values, we have 20 times logarithm of 200,000, which is this one, divided by 6.3. Ito yung posibleng maging gain ng ating signal, yung nasa taas. Ito yung posibleng maging gain ng ating noise. Ideally, this should be very, very, very low. But practically, it depends on what type of op-amp ang gagamitin natin. So this is equal to 90 decibels. All right. The minimum specified CMRR is 70 decibels. So this is actually a good number. So it means that yung 90 decibels na yon mataas for the CMRR. So the ability of this 741C op-amp to reject noise and to amplify signals is high. Let us now proceed to the other parameters ng ating operational amplifier. The next parameter is what we call the maximum output voltage swing. Ito yung pinakamataas at pinakamababa na pwedeng maabot na amplitude ng ating output signal, pero saan ba siya nakadepende? Ang value na ito ay nakadepende sa ating mga power supplies na ginagamit to power up these devices. There are operational amplifiers na kinakailangan ng dual polarity. Merong mga operational amplifiers na nangangailangan ng single polarity. So gagana na sila using just a single power supply. One op-amp na usually ginagamit ko is the LM741. Usually ginagamitan ko yan ng dual polarity power supply. For example, ang ginamit kong power supply, by the way, ang power supply natin for the op-amp is called VCC. Parang power supply ng isang common emitter. Alright. For example, gumamit tayo ng plus and minus 15 sa ating LM741. Theoretically, ang pinakamataas natin na amplitude sa positive side ng ating output should be 15. And ang pinakamataas dapat sa negative side ng ating output should be negative 15. So theoretically, we should have a maximum of 30 volts peak to peak. But that is not the case. Depende sa op-amp na gagamitin natin, yung magiging moves natin or maximum output voltage swing. Typically ako kapag nagde-design ako ng mga circuits using op-amps, I always check the data sheet. But if pressed for time, usually I assume a plus and minus 1 volt para sa aking moves. So for example, if I have plus and minus 15, I assume there's a plus and minus 14 volts for uh, uh, the positive alteration and the negative alteration of our output signal. Ideally, ang op-amp, kapag wala itong input sa kanyang mga terminals, ang output dapat is equal to 0. So kapag naglagay tayo ng input sa ating mga terminals, when we apply inputs to its terminals, it should be amplified. The next parameter of op-amps is what we call the input offset voltage. Before we go into that, no, like what I've said a while ago, ang op-amps kinakailangan ay walang output kapag walang input. But practically kasi, ang mga op-amp, merong mga onting mismatch dun sa base and emitter junctions ng mga diff amp. Remember, ang first stage or ang input stage ng ating op-amp ay mga diff amp. Yung diff amp natin is made up of 2 NPNs. Yung dalawang yon usually merong mismatch. So kapag meron tayong mismatch between those two base emitter junctions of the two NPNs, nagkakaroon tayo ng output voltage kahit wala namang input. Alright? So that is what we call the output error voltage. So how do we eliminate this output error voltage? Okay? So with the different types or different models of op-amps, meron tayong mga ginagamit na circuit connections. It's also based on the pin configuration ng ating op-amp. Alright, so let me show you the data sheet of the LM741 that is manufactured by National Semiconductor. Although there are different companies or manufacturers na nagagawa din ng LM741, hindi lang National Semiconductor ang nagagawa nito. TI or Texas Instruments gumagawa din ng ganito, no, and others. For this one, we have the Metacan package, which is circular, and meron din tayong yung dip, no, yung dalawang hilera, the dual inline package, Kung mapapansin natin, meron tayong tinatawag ditong pin na offset null and the same with the dip one. Right? So para saan ba yung offset null na yan? Ang offset null na yan ay nagkakabit tayo ng external component para yung output error voltage natin ay mawala. Di ba ang objective natin, kapag walang input ng op-amp, wala rin siyang dapat output. So this is how we zero out the output error voltage using the LM741. We have what we call the offset nulling circuit. So nakalagay dito ngayon kung paano natin i-connect yung ating 10 kilo ohm na potentiometer doon sa ating op-amp with an external negative supply. So this is applicable for the LM741. Kapag meron tayong ibang klaseng op-amp, it may be yung ating offset nulling circuit is different from this one. All right, so again, this is needed to zero out the output error voltage. So balik tayo dito no, sa input offset voltage. Yung input offset voltage is actually the amount of voltage na kinakailangan natin doon sa differential inputs natin para mag-zero yung ating output. So paano tayo nagkakaroon ng ganito? By utilizing the offset nulling circuit ng ating mga op-amp. Kagaya ng ipinakita ko kanina doon sa ating LM741, kapag ginawa natin yung circuit na yon, it will provide an input offset voltage at your differential inputs in order for the output to be zero. Alright? Ang op-amp actually nakakapag-amplify yan, it's because of V sub D. But I think na-discuss naman ito in your previous class, but nevertheless, papahapyawan ko siya. Ang op-amp natin, kinukuha ang difference nung dalawang input. So let me just go back to the diagram of your op-amp. So ang ginagawa ng ating op-amp is kinukuha niya yung difference nung dalawang input natin, and that is called V sub D. Alright? Pag minus yung dalawang yan, that is called V sub D or the differential input voltage. Yung V sub D na yon or the differential input voltage, yun yung ina-amplify ng circuit para magkaroon tayo ng malaking output. Alright? So kinakailangan daw, kapag wala tayong input dito, wala rin tayong dapat na output. So yung input offset voltage na tinatawag na yon is the amount of voltage dito sa input natin to zero out the output when the input is zero. And again, we can attain that by utilizing the offset nulling circuit ng ating mga op-amp. Ang susunod na parameter ng ating op-amp ay yung tinatawag natin na input bias current. Ano ba tong input bias current na to? Ang input bias current, ito yung kuryente na kinakailangan ng ating operational amplifier para ito ay gumana ng maayos. So, meron tayong range ng kuryente na dapat pumasok sa ating inputs para ito ay mag-amplify if it is used as an amplifier or para ito ay mag-compare ng dalawang signal voltages if it is used as a comparator. Ipapakita ko sa inyo ang isang example ng input bias current, again, using the LM741 op-amp. Going back to our data sheet, again, this is the LM741 being manufactured by National Semiconductor. So from your data sheet, nakalagay dito yung input bias current natin. For example, gagamitin natin is yung LM741C. All right. So the input bias current of LM741C is from 80 to 500 nanoamperes. So yan yung mga values nila, no? Normal operating temperature of 25 degrees Celsius. So ibig sabihin nito, kinakailangan yung kuryente natin sa input ng LM741C ay maglaro sa pagitan ng 80 at ang 500 nanoamperes. But take note, di ba ang theoretical value dapat ng ating input current should be 0. kasi nga napakataas ng input impedance ng ating op-amp. So that's the ideal or the theoretical value. But ang ating current is really not zero practically, no? So it depends on the type of op-amp na gagamitin natin. So kagaya na lang itong example natin is from 80 to 500 nanoamperes para siya ay gumana ng maayos or para ma-detect niya yung ating input. If it is outside this range, hindi gagana yung ating op-amp. Hindi niya ma-detect yung ating input. The next parameter is what we call the input bias current. So this is another current has an equation value that we have to consider. I so it's sub bias equals I sub 1 so input plus I sub 2 divided by 2. This basically ang ating input bias current is the average I sub 1 of the current minus I sub 2. The two inputs. So this is the difference and between the base yung dalawang input na to ay yung dalawang base or ng ating this is the difference between the input currents. Diba ang first stage or ang input stage ng op-amp ay diff amp. Ang input ng diff amp ay base ng NPN natin. Therefore, itong I sub 1 tsaka I sub 2, these are both base currents. Take note of that. Ang I sub 1, ito yung kuryente ng ating inverting input. Ang I sub 2 naman, ito yung kuryente ng ating non-inverting input. So kung i-compare natin ang input bias current at ang input offset current, ito yung pagkakaiba nila, no? Ang input bias current is basically the current that is being drawn by your inputs. Ito yung pumapasok dun sa input terminal ng ating op-amp. While itong input offset current ay ang pagkakaiba or difference nung dalawang kuryente na yon. So depende sa op-amp na gagamitin natin, no? Later on, I'll give you the example of the input offset current ng LM741. Meron tayong acceptable range for that. Going back to our data sheet, no, the LM741 again, we have the input offset current at 25 degrees Celsius again. So this is the normal operating condition or the nominal operating condition for the temperature. No? For LM741C, we have typical values of 20 nanoampere. So it means that ang difference daw dapat sa kuryente natin sa input should be 20 or ang pinakamataas na dito ay 200 nanoamperes. Anong ibig sabihin kapag lumagpas na sa values ng 20 to 200 nanoamperes? Ang ibig sabihin niyan is meron tayong diferensya dun sa ating circuit or maaring merong diferensya yung ating op-amp. So ang input offset current is a value that dictates or tells us na merong diferensya dun sa ating input current o baka merong diferensya na yung ating circuit or yung ating op-amp. So kung LM741C ang ginamit natin, dapat ito lang yung range niya. So from 20 to 200 nanoamperes lang yung diferensya. Now let us proceed to the different impedances ng ating operational amplifier. So the first one, we have the differential input impedance. Ang Z sub in, D, ay ang total resistance sa pagitan ng ating minus at ng ating plus inputs. Remember, ang input impedance ng ating ideal op-amp should be infinite. So itong ating Z sub in D has a very high value. The next one is what we call the common mode input impedance. This is different from the first one because of the manner in which it is measured. No? So ang measurement ng ating common mode input impedance is between the input terminal and the ground. So kung meron tayo ditong input terminal at ito yung ground natin, ito yung resistance natin. And kung meron tayong input terminal dito and ito yung ground natin, ito yung resistance natin. So this is common mode input impedance and this is also common mode input impedance. So depende lang siya kung saan natin sinusukat or saan natin kinukuha yung impedance natin. Is it from the inverting input with respect to ground or is it from the non-inverting input with respect to ground. The third impedance is what we call the output impedance. If you can recall, ang ideal value ng ating output impedance should be equal to 0. Kasi kung maglalagay tayo ng load dito sa output, kinakailangan 0 to para lahat ng output natin mapunta dun sa ating output. But practically, ang mga operational amplifiers, merong small amount of output impedance. So magkakaroon at magkakaroon pa rin tayo ng voltage divider. Kung meron tayong output dito, output voltage, mahati ito sa pagitan ng Z out at ng ating load. Alright? That is why it's very important for our Z out to be very small para majority of your signal will go to the load. So those are the three impedance parameters ng ating operational amplifiers. So one more thing, no? So ipapakita ko lang yung example ng value ng resistance or impedance ng operational amplifier from the datasheet of the LM741. For this one, ang pinapakita dito sa datasheet na to is yung input resistance. Input resistance is also your input impedance. Ang value, for example, ng ating LM741C, ang typical value niya is 2 meg ohm. So as I've said, malaki talaga ang input impedance ng ating operational amplifier. Okay? So that is why yung kuryente natin sa input, no, is very small, practically small, but ideally zero. It's because of the very high input impedance or input resistance ng ating operational amplifier. Hanggang dito muna tayo. At I hope you understood the basic parameters of operational amplifiers. Kung meron kayong mga katanungan, please post it in our group and I'll try to answer it right away. Meron pa tayong isang natitirang virtual class on comparators. Probably I'm gonna upload it next week. So stay tuned for that. So that would be all. Thank you.